We're starting another class. Just for me to recap on what we have done last week before I continue what we are going to do today. Well, for today's lecture is going to be two-phase. I'm going to start and complete some of the um, testing principles and keeping testing up. Once I finish that, Patricia will take over from there. Um, well, let's start. So yeah, I'm starting just a recap on what we did last week. First is we talked about the background of testing. I gave some examples, which has to do with different examples on testing. I actually told everyone, spoke also about the references, and everyone that sent that email, I'm sure the admin has sent a soft copy of the textbook to you. So I hope you've read about what we did last week. Also, we talked on some of the topics that we are going to work on, which has to do with functional testing principle, which is the next phase. All the topics we are going to work on, I spoke about that. Then I said the objectives of what we are going to do in testing, manual testing generally. So that is what is testing, how testing is done. Why is testing necessary? General principle of testing, fundamentals of testing, then assessment questions. Also, I also spoke on the objective. Why is testing? What is testing? Why is testing necessary? The general principles of testing, fundamental of testing, and assessment. Which I also saw what testing is. I said it's testing for, we know now that testing is for everyone. These are the testing disciplines, which I spoke about in the last class. Also, I talked about testing as a discipline. Also, I said who can test? Anybody can. Instead, that's hardware, physical devices, laptop, and software, something that cannot be touched. Then software testing. I've just started dwelling on software testing, started talking about what the software testing is. How can it manually and automatedly? Manual testing, that is the class we are doing now, and automated testing, that's the class done on Monday, which is the Java class, that's automation, and any other language, which is, it could be C#, it could be Python, Ruby, those are object-oriented language that you can test with. Also, I said, why do we test? Which I explained, going with error, defect, failure, the reasons why we test, the consequences of we not testing properly, all that I did explain in the last class, and I talked about error, defect, failure. Also, I explained examples of error and defects, failures. Now, I spoke about keeping software under control. So that's where I'm just going to start from today's class. So keeping software under control, which I explained last week, I said exhaustive testing is complex system is not possible. So which I when I explained last week, I gave an example of a complex system, and the reason why this phrase is, or this is exhaustive testing of complex system is not possible is because there's no how we cannot test everything inside a system. We wish to test it, but not to forget, I said there are deadlines, there are times for us to stop testing. We need this product to come out, we need this system There are clients waiting for this system to be put in public so that, yes, people can start using it. So we have deadlines. That's why we cannot test everything. But in a phrase, you can also do prioritize your testing, and that we are going to dwell more as we go along in this, as we go along in the course. How to prioritize your testing, the ones you test first, because when you're talking about testing, you need to put some qualities and some yes, what I'm going to test. How am I going to start testing this system? What are the priorities? What are the risks? Those risks has to be tested first, so that in case they tell you anytime, please can you stop testing and put the product to life, you will know you've covered those risks before before you now giving the system out to say, oh, to the public, people can start using the system. So if every possible test has been run, the problem would have been detected. That's if you are running all the tests, checking all the system, doing your test properly, definitely you find defects. And don't forget that the reason why you are a tester is for you to find defects, find what is wrong with the system. That is the major thing you are there to do. As I've said, there are levels of testing. If you test first, and another person tests, and another person tests, we will all find different defects and different errors. So, however, if every test has been run, the testing would still be running now. And if maybe we'll launch, let me give an example. For instance, let's use a new car. You've tested everything in the car. You checked the windscreen, you checked the brake, you've checked that yes, it's got a wheel, it's got XYZ in the features. And everything is working as expected as at the time you check. When I said check, as at that time that you're testing, all your necessary steps have been taken. You have looked at it, there is an engine in the car, the wheel is working. Once you move, of course, I can move the car, I can apply the brake, there is a door, body falls off the car. When I apply the brake, yes, the brake is firm. It doesn't mean that if you drive that car carelessly or you're over speeding, that the car won't have an accident. We have that we have to test towards. As you are going along, that will be explained more intuitively for us. So, majorly, what exhaustive testing of complex system, why it's not possible, is because there's no how you can tell me I've tested that yes, even if this car speeds, it cannot have accident. It's impossible. You cannot guarantee to say if I run carelessly with this car that it's not going to have an accident. It's not possible. So that's why that's why exhaustive testing of complex system is not possible. Take any other system, a website too, you can say, oh, when the traffic in that website, when 10,000, maybe when you're testing, you tested with your stress and load testing was maybe for 100 people, and it worked perfectly. When you tested 1,000, it worked perfectly. Now, don't forget, it's not 1,000 people, it could be millions of people using at that time, and it could crash. It doesn't mean that because you have tested it, that yes, it's not going to crash. No, it might still crash. So that's why work in progress and things like this go on when it comes to software. So that's that about exhaustive testing. Now, when is testing enough? When is testing enough? When is testing enough? We'll talk about testing and risk. We'll talk about testing and quality. Then we'll talk about deciding when enough is enough. Testing and risk. Risk is inherent in all software development. The system may not work, or the project to build it may not be completed on time. So what he's trying to say is that, of course, the risk of testing, when you're testing, what are the risks? What happens? What can happen? You might be given a system or a project to work on, and they may tell you that this project, our deadline is is in the next 24 hours or 1 week. We need this system out. Not to forget, you are not the only one working in a team. It's a big team. Before it gets to testing, someone is going to put it down. We have the requirements gathering done by the BA. We have the BA to move that to the developers to tell them this is what we want in the system. Developers to have their own time to build something up. After then, it comes to testing. This is a process. When you are given from point A, from the BA to the developer, then you are at the last end of it to test it. Where do you come in? So when you start testing at that time, I said 1 week, develop business analysis to 1 or 2 days. A week is 7 days, 5 days in that week. After 1 or 2 days, he hands it over to the developer. The developer uses maybe like 3 days to complete it. You've just got 24 hours to get it tested. But you would have started your own testing right from when the requirement is being gathered. That's when you start writing your test cases. What are my priorities? What am I going to set? What are the risks in this testing? Because, for instance, the risk of how you are going to test, maybe like a airplane or a car, is different from when you are testing a video game. You know, in a car, if you don't test it properly, there might be consequences of that. Loss of death, loss of lives. So there might be death. But video game, we're just talking about games. So the way you are going to test a car, a car, is different from the way you are going to test a video game. So that is where you now bring, when you're gathering your test cases from the start, you will know what to test first. What are the things I need to test quickly before they give it to me? Of course, the brake is paramount. That car to apply brake at any time. If I finish that, then does he have it on to tell people I'm coming on the way? Can you move? Does he have a steering? How am I going to move the car without a steering? So all those things. Does he have a windscreen? Does he have a door? All these are priorities. So now, if you tell me everything is there, if it doesn't have a seat or this, so you just do the priority and you test properly before it now goes in. So these, we don't know what can happen when it comes to when you're testing and the risk. You need to weigh the risk and testing together. So what is testing and quality? Testing and quality. Well, I'll just say, of course, if a system is working as expected, you know that yes, the system is got good quality. So when you're talking about testing, you're talking about the quality of it. So if I say this software, when I go into, let's say, for example, I want to go into a website, take maybe Gift Treat or something, Gift Treat as an example, and I go into the Gift Treat, there are things to look out for. Before I can go into Gift Treat, I need to register. What do I see? Yes, I can register as a user. Is working as expected. I can log in as a user. It's working as expected. The system, I can go to each community. I can add items. I can remove items. Everything is working as expected. Then you say, oh, this system has good quality. It's working as expected for me. So that's the way testing and quality works. In testing and quality, we have a triangle. there. They call it the resource triangle. Resource triangle. It talks about time, money, quality. Resource triangle. It talks about time, money, quality. So we are talking about the time, the money was spent, and also the quality of the system. And all these are embedded when we want to get a project or a software out to make sure that yes, it's working as expected. So you're talking about time, money, and the quality. How long is it going to take us? What is the money, the resources? When money comes in IT, you're talking about resources. Who are the people going to work there? We have a developer, we have the BA. What money, how are we going to spend it in each project? So part of the resources in those projects. What quality? Do we have good quality of the system? Is this system working as expected? When I log in, am I going to the landing page? What happens after then? Can I navigate from one place to the other? Those are good quality of system. So that's when you talk about testing and quality. So now the reason why they are saying when is testing enough. So when is testing enough, you need to first weigh the testing and the risk. So your first priority is to check what are the risks. The second thing is that, oh, is this working as expected? What is the quality of it? Then the third thing will be, when do we decide? Deciding when enough is enough. As I said earlier, we wish to finish all the testing. When I mean I wish that yes, we can finish all the testings to say, oh, in this letter is not there, this is not there, checking the nitty-gritty and everything of what you're testing. But not to forget, time, you have to meet deadlines. That is the reason why you have to prioritize whatever you're doing. So you need to meet deadlines, things need to get out, because if you don't meet deadlines, how will they make their money? They spent money on the system, how will it go out? So you need to put all these things in place when you're testing. So how much testing is enough? And how do we decide when to stop testing? We have so far decided that we cannot test everything. Even if we would wish we could, we can't do. So we also know that every system is subject to risk of one kind or another, and that there is a level of quality that is acceptable for a given system. So, of course, different systems have different ways of complexity. The way I said you can test a car is different from the way you can test a video game. So the way you are going to prioritize your testing when it comes to testing a car will be different from the way you are going to take it when it comes to testing a video game. So that's when you decide when is enough time for you to test. So when you are asked that when is testing enough, first, testing is enough when you have checked that the risk, you have tested every possible value, every boundaries, every partitioning, every principle, the decision table, you have covered everything. You have checked the risk. Then you have seen that yes, I've tested all the risk, everything is fine. I've looked at the quality of the system. Is it fine? Can I do the essentials? Can I log in? Can I do this? Can I drive? Can I move to this? Can I navigate? The quality is fine. Then you can now say, oh, I have decided this is enough. And I've said it even when in the course of the lecture that every company has different way they actually say, oh, testing is enough. In financial organization, maybe you're testing ATM, they're looking about validation, verification, checking your pins. Nobody can read nobody can read whatever is at the back of your card. So there would have been a yardstick for you to know when is enough. Have I covered all the risk? Have I looked at the quality of the testing? And have I seen what happens at the end? So this is when you can say, I am fine. You can take this testing to life. After that, we are talking about the general testing principles. General testing principles. We've got 7 of them. Testing shows the presence of bug. Everyone will agree with me that testing shows the presence of bugs. What your job as a tester, which I've said, and is for you to find bugs in quote. But it doesn't mean that if you don't find bugs, it doesn't mean that yes, or that system is not working. Of course, there are enhancement updates on each system. So, but the major reason why you are testing is to show the presence of a bug. So I'll say running a test through a software can only show that one or more defects exist. Testing cannot show that the software is error-free. And that's what I've said, that the software, testing does not show that testing can tell you that yes, it's error-free. So the reason why we are testing is to show the presence of bug, but it doesn't tell you that yes, you can't say is error-free. There are some errors that will slip through, but the major thing is for you to make sure that you have tested and you're confident with whatever you have tested. Also, exhaustive testing is impossible. As I've said in exhaustive testing above, if testing finds problem, then surely you would expect more testing to find additional problems. If there's a problem, we are sure that yes, let me put it in this way, before you get a system, not to forget, developers to have done their testing. That's where they have done their own testing on their own local. That's their own machine, their own environment. After that, then it moves to you, to the test environment for you to do. So it doesn't mean because they have tested, that is one person testing. And when another person start testing, he's going to find a different bug. What you see as a bug first, you might think you have finished testing, or it's fine. But when it moves to the next one, you will see that yes, is actually is that there are other bugs. So that's the reason why it would actually find additional bug whenever you are testing. So exhaustive testing does not mean that if you are given a system to test and you keep testing that same system, testing it. Let me give example of maybe you are given a textbook, just one page to look for the bug. And it's a long textbook. You have been reading that textbook from A to C. You have found that yes, THE is written as TEH. You have changed it. You have gone again. Cost is written as CTOS. You have changed it. After a while, when you keep reading that page, you might not find anything again. But now, take that page, the same page that you have found the bug that, oh, I can tell you 100% that this page is fine. You can give it to another person to test it. I will find a couple of things. Oh, you didn't look at Anne. You didn't look at this. You didn't. It doesn't mean that you have not tested it. So exhaustive testing is impossible. Early testing. What is early testing? Early testing is you starting testing right from the beginning. We have introduced a project, maybe a new project is starting in the organization. Say, like we've got a new project now, let's say like property rate is a new project. It's starting as a new project. Oh, this is what we have, and you've been told as a team where early testing comes in. You all gather, you are inside oh, this is the new project we're going to do. They've explained to everyone. Now, there's a kickoff meeting. You start from there. Testing, the earlier you start testing, the better for both the organization, the business, and also for the team, and also for you as a tester. Because the earlier you catch a bug, the better for the organization. When you catch a bug at point A, before it moves to point B, it's easier to fix at point A. Let me give you an example. Say, for instance, in your new car or your new phone, you've got a new phone, and that is the new project you want to work on. Or let's take a website at first. A website. If the website, the first thing from the website is for us to have a login page. That's it. Now, we don't know how the login page is going to look, what is going to happen. But your expectation is we have to have a login page. So if you are going to have a login page, the earlier you catch that, the earlier you start with them to say, oh, in this login page, you as a tester, you are involved with both the business analyst and the developer. Because you all need to understand, you as a tester need to understand what you want to test. So when you start with the requirement, the business analyst comes in and tell you, oh, the requirement says that we should have a login page. Now you come in, how do you want the login page to come? You'll start asking your question. The login page has to be, oh, how do we log in? What are the characters? Is it with username or is it with email? What are the things that it's going to take for the username? What are the, how is the password going to be configured? How many characters? Those questions you would have asked. Now tell me, if the business analyst had just said, oh, okay, maybe, that's true. He's very right. She captures it at that beginning. We've not started development at all. He's just written. The only thing that is going to suffer at that end is just for them to change the person to write and say, oh, we need to capture how the login process is going to be, the username and the password was going to be on that page. Do you know you have saved the company or the business after they finish developing and they give you, maybe you were not in the meeting with them, you didn't contribute, you didn't test early, and they give you at the last end after then, and you're now saying, oh, what are the requirements? Of course, I can go into this. They will have to go back, starting again all over. Now, I said resource triangle: time, money, quality. Look at the time they have spent to build it before it gets to your end. Now, look at the money, the resources. A BA has been involved, doing meetings up and down with the developer. He's done everything, used some of the resources and given it on to you. Then we are going back again. So it's like we wasted the first bit of the money. Now you're coming back to start again. So the earlier we start testing, the better for us. Then defect cluttering. Problems do occur in software. It is a fact. Once testing has identified that most of the defects in a particular application, it is the first surprising that the spread of defect is not uniform. So let's say for defect cluttering is, we know what the meaning of defect is. So it cluttering is just like it gathering somewhere. So if you find the defects quickly, then there won't be any problem for it to gather anywhere. And this starts from there is a process of writing the code. If it's found earlier, is is actually good, and is good for the business, which will help every one of us. If it's found in small numbers, maybe like now, you find a line of code, oh, this login process is not right, and it's quickly fixed at that point. It won't extend. It won't keep staying until it gets to the last end when it blows up. Blah. So it won't stay up to that point, but it's going to, the defect once it's found at early is corrected. Next module, that's in a bit after this is corrected in the login. When you are using the same login, not to forget that same login is what you use to land on that page. So if that login, if you were able to land on the page and that login was not corrected, at the long run, after you finish, when you navigate, when you log out, when you want to log back in, it might not allow you to log in. So all the defects would have cluttered till the end. Oh, just let him do whatever he wants to do. When he finishes, we'll sort that. Then after that, so the defect cluttering, the earlier you find the defect, and yes, you find it quickly, you can fix it in small modules. So there's a defect cluttering. Then what is the pesticide paradox? Running the same set of tests continuously will not continue to find new defects. Developers will soon know that the test team always tests the boundaries of conditions. So that's what I've explained when I was telling you about exhaustive testing. So for the pesticide paradox, it's saying that if you are testing continuously, it doesn't mean that, yes, you find a bug in that. And that is why we have a series. The way we test, we look at test conditions. When we take a condition, like you have a login condition, now you've got, what am I expecting to see? Expected results. In the login, I'm meant to see a username, a password, and how do I write the password in Yemi 1? And I put password P capital password 1. That is what I'm expecting to see. When I go there, if I'm not seeing what is there, then I will know that the actual result of whatever I'm seeing, what I'm seeing currently, is not in line with that. So it does not mean because I keep testing and testing that there's nothing wrong with that system. No. What I've been saying is that when you test a particular system often and often, it doesn't tell you that it's error-free or that there is no bug there. No. Someone else can test it and still find bugs. So majorly, the pesticide paradox is just saying it doesn't mean that, yes, when you continue testing and testing, it makes it error-free. No. So we are talking about testing is context dependent. Different testing is necessary in different circumstances. A website where information can merely be viewed will be tested in a different way to an e-commerce site with goods. So with goods that can be brought, maybe using credit card and using credit card and debit cards. So in a nutshell, what it means is that the way you're going to test a normal website is different from the way you're going to test an e-commerce website. A normal website where no payment is involved. I'm just going into into after I log into gift treat. I log in. After gift treat, I see a landing page. Choose the community. Choose a community. I just send a picture and I post whatever I have there for people to view, and if they want it, they can get in contact with me. That's simple. No money involved. Nothing. The way you're going to test that website is different from when I go to maybe like an online grocery shop where I've finished doing all my groceries and everything, and I need to make a payment. Now, payment, we've got the card details, either your credit or your debit card. The way I'm going to test that is going to be different from what I'm going to do when it comes to the website. So that one now is majorly, maybe I'll do validation, a verification testing, just to ensure that nobody else, after if I finish paying, can use that same card again that doesn't have the same details, or when any other person log in after them, he doesn't see the details of the card. So all those have to be checked and put in place, and that's where testing is content based, so context based. So it depends where you test a normal website is different from where you test an e-commerce website. So absence of error fallacy. So what absence of error fallacy is saying is that software with no known error is not necessarily ready to be shipped. Does the application under test match up to the user expectation of it? So what is actually saying is that software with known errors, it doesn't mean that yes, is actually, of course, maybe it's not, is ready to go out or is not ready to go in. So you can't say maybe absence of error can give you guarantee that yes, this system when it goes out, nothing called bug can be in that system. So that's where the fallacy is. It's just trying to say absence of error does not mean that yes, the system is working as expected. No, I can still find a bug. We still use live systems now. I can give several examples that there are a lot of bugs in it. But of course, we still go on and still use that same system. So that's the way it is. So general principles of testing goes, testing shows the presence of bug in a literal meaning. Yes, it shows the presence of bug. Exhaustive testing is impossible. Definitely. We can't say that yes, without that is testing. Exhaustive testing is impossible. Early testing, testing quickly, starting testing right from the beginning will reduce. Is kind of very good when you start early testing. Early testing, there are more. All these general testing principles are still going to be explained in most of the things that we are going to be talking alongside when it comes to the life cycle of testing. So when you talk about defect cluttering, so ensure that yes, the defects are being captured quickly before in bits before it actually goes to clutter. Pesticide paradox. It doesn't mean that yes, testing all the time is showing that yes, it's error free. There might still be error. You might look at this page several times and still not find error in it. I might take the other page and look at the same page and find error. Testing is context dependent. The way you are going to test a website is different from the way you are going to test a normal, is different from the way you are going to test an e-commerce website. Absence of error. What absence of error is absence of error fallacy. You can't say because there's no error there, the system is already ready. No, it might still be, there might still be a problem there. So that's the general principle of testing. And for my bit here, I'll say fundamental testing process. Fundamental testing process is the next step we are going on to. So the fundamental testing process, A is testing, test planning and control. Test planning and control. So test planning and control. You're talking about planning. In testing, the way when you read some statements, you actually be able to deduce what this is talking about. I'm talking about test planning and control. When you do test planning, you'll be able to control your testing. That's where prioritizing, doing that quickly, all this is embedded with both your test planning and control. So from my notes here, I said planning is determining what is going to be tested. Planning is determining what is going to be tested. In this same course, this manual test course, this manual testing, we're at the end of it, we're still going to talk about test planning, test strategy, how to write it, and what are entailed in test planning. So if planning is determining what is going to be tested and how this will be achieved, it is where we draw a map, how activities will be done, and who will do them. So test planning, control. When we do the test planning, who are going to do it? So at this phase, we are saying in test planning, we are going to do this type of testing, maybe functional testing, non-functional testing, regression testing, retesting, all this kind of testing. Who are going to do them? Who are the resources we're going to use? Who are going to do the manual bit of it, the automation bit of it? How are we going to do it as a team? It's just majorly planning and knowing the resource and the people to work on this. That's test planning and control. So test analysis and design. What are we talking about? Analysis, design. How do you have to analyze your testing, your test cases, and how it's going to be designed, the whole test script. So in my own note, I just said analysis and design are concerned with the fine details of what to test. That's the test conditions. And how to combine test conditions into test cases. So in test conditions, the analysis, we talk about the test condition and how it forms to have different test cases. So for instance, if you go to the hospital to say, oh, I want to see the GP, or you want to see the doctor, and you get to the hospital, of course, maybe patient is having headache. The doctor I get there and I stand in front of the doctor. He can only see maybe I'm a female, I'm a male, I'm standing up. That's the only thing. If I don't open my mouth, if I don't say I'm having headache or anything. So the first thing he sees is you that you're standing there. That's the test. You are here now, the test condition. So now, where to define a test condition? If I say, doctor, I'm having headache, it will write the test condition as headache. Now, before the doctor consider that, yes, really, you are having headache, he needs to ask some test cases, some steps. Why did you say you are having headache? Oh, I'm having ache on my head. You write having ache. That's one of the test cases. The next thing is say, how do you know you are having ache? Press here. I press the forehead. Is doing this. I press this. Those are he has his own cases. The test, how is going to find out that yes, really, you are having headache. You can't just get there to say, oh, I'm having headache. And you say, yeah, that's fine. You're having headache. And you just tell you take paracetamol. He can't just bring it up like that. He needs to find a case to be able to say, yes, really, Yemi, you are having headache. Before he can now say, I expect you to use XYZ drug. The same thing, that is with test condition and test cases move. I get there, I've taken login as my test case, my test condition. What are the steps? What are the things that I want to do there? In the login, I want to use a username, the password. I need a submit button. I need a forgotten link. After I click that, then it should give me this and that. So that is analyze and design. Test implementation and execution. Implementation and execution. When you implement something, after you have done all this analysis, the design, the control, everything, you've implemented that. Now you want to execute it. So you want to run all those test cases. So in my note, I said the test implementation and execution activities involves running tests. So as I said, execution is you running the test cases. Now, I've written the test condition of the login, username, should have a username, a password, should have a forgotten link, I should have a submit button. That is my expected result. That is what I want it to have. Now, my execution goes to when I start running it. I have gone to give treat. I have put a username, Yemi, and I put the password 1. I click the submit button. Yemi, what happens? Oh, it went straight to give treat landing page. Ooh la la. So I'm there. So which means it shows that yes, really, that is working as expected. So that is what I am seeing now. My actual result is I am seeing a landing page, and this is what is expected of me. So that's evaluating exit and exit criteria and reporting it. So we are going to also speak about exit criteria, and also we have something called entry criteria. Exit, going out. I'm going out. Evaluating exit criteria and reporting it. So exit means you're going out. Entry means you're coming in. So how do you start testing? When do you want to stop testing is the criteria. So in my notes here, I said, remember that exit criteria were defined during test planning. That's going to be part of the test planning. You are going to see the process when we start. So, and believe that test execution started. At the end of test execution, the test manager checks to see if they have been met. So which means is all your test cases, have they been met? How do we define that yes, this percentage of the tests have been done? If the criteria was that there would be 85% statement coverage, then we can analyze. So if for instance now I've got 5 test cases, and out of that 5 test cases I've executed the 5. 3 of them passed, 2 failed. In testing, you don't say the 5%, the 5 test cases that I have executed. It shows that is 100%. I'll come again. I've got 5 test cases. In that 5 test cases, I executed 3. That's maybe for the login, the username, the password, the submit button, or the submit button, and the. So it's just the 3 that worked. The link for the forgot password is not working, and also some link on the web page is not working. So what I do is that 5 test cases, 3 of them passed. The 5 represent any amount of test you have. They all add up to 100%. Now, when your test manager comes to you to say, Yemi, how many of these, when you want to report it to the test manager, you won't say, no, 3 of my test cases passed out of 5. No. You have to change to say 60% of the test cases passed, 40% failed. If you have a summary report, you can give it to them. Then they can map it to see whether they can move. In some companies, they might tell you if 85% passed, Leave the system, let it go out. Some might say if it's 75%, let it go. But if it's 85% and 60% pass, you yourself, if they ask you, can it go out? No, it can't go out because the the company policies is that says that 85% of the test can go, but 60% have passed. So if they tell you sign it off, you say no, I can't sign it off because 60% is not is worked, and our yardstick is 85%. I've checked the risk and the quality of the testing. There's still some risk to be covered, so I can't tell you that I can sign it off. Yeah, that is absolutely okay from your. So evaluating exit criteria and reporting it. Then for the last one, for the fundamental test process is test closure activity. Closure. Closing the when to say is enough. Testing at this stage are finished. You've completed after you have done all this process. Test closure activities concentrate on making sure that everything is tidied away. Report written, defect closed, and these defects differ for another phase, clearly seen to be such. So at test closure, after running all your tests, you must make sure that everything that needs to be tidied up is tidied up. There's a report written. This is what I have done in my test. This is the page of the report, and it's being sent over. Then is the closure. We finished up. So those are the fundamental testing process. Test planning and control, test analysis and design, test implementation and execution, evaluating exit criteria and reporting it, test closure activity. The philosophy of testing. A variety of different people may be involved in total testing effort, and they may be withdrawn. They may be drawn from a broad set of background. So we are talking about some will be developers, some professional testers, some will be specialists, such as maybe performance testing skills, maybe they've got security testing skills, all these, while others may be users drafted to assist within acceptance testing. So this is just a broad life of the testing background. So just a recap on what we did today. For me, keeping software under control, exhaustive testing of complex system. When is testing enough? These are the principles: testing and risk, and testing and quality, deciding when is enough. Then we've talked general testing principles and fundamental test process and the philosophy of test. So it's just Q&A. If you've got any question before we proceed, I need to hand over to Patricia now. So any question for just a few minutes? Questions, please. Okay, someone said, who defines the criteria? Is it the test manager? So you can define the criteria yourself. If you are test manager and you're given a process, okay, let me say you are in a team, you are in an organization, you've got maybe 5 testers, you have 5 projects or more. They won't put 2 testers in one project. No, it will be 1 tester in 1 project. Then the hierarchy will be test manager, distribute them. Project A, B, C, D, E. You are in project C. Your test manager just knows the high level. You are the one to define your criteria. That's why you sit and work along with your team. Talk about the BA, look at the requirements yourself, draft your own test cases, give it back to the team. These are the risks, these are the gaps. They fill it, you write your test case, so you define the criteria yourself. Please, what is the difference between entry and exit criteria? Entry is when do I start? When are we going to start testing? What time, when are we going to start testing? So you started testing you started writing, designing your script and the likes. So exit is when to stop testing. So all the things you have prioritized, I've said, look at the risk first. Put it as your priority. This one is a must. Is a must for you to test. Put other ones that are needed. Then at the long, you will know that entry is just the beginning. Exit is when to end it. Please, what is written? Please, what is written that is not philosophy? Psychology. No. Yes, psychology of testing. Yes. Sorry, it's psychology of testing. Is is there difference between testing in agile and waterfall? Yes, there's different. Someone said, is there difference between testing in agile and waterfall? Yes, there's difference in testing in agile and waterfall. Patricia is the next person. She's going to talk about that today. Yes. In any other question? In absence of any other question, I'll hand over to Patricia.